for this printer. It's called the Form 4. And it is a resin-based printer using MSLA is what we call it, Masked Stereolithography. So basically the whole idea is that instead of relying on a laser, we have moved on to an array of 60 very powerful LEDs. So what you see here is an optical baffle that is actually taking the light, which is underneath, the LEDs are underneath, and then it's collimating that light into very parallel, uniform light beams that will then go through this LCD screen. The LCD screen is going to mask the shape of the parts that you're making. It goes down and up like this, and then each layer will cure with the light source layer by layer. Because of the new technology, it's 3 to 5 times faster.
I see. And how much does this cost, for example?
Okay, so the printer itself is $4,300. However, with the washing station and the cure, the complete package also includes like a professional service plan, consumables, $6,300.
All right, cool.
Over on the left, you have like our general purpose materials. These are used frequently for prototyping, functional prototyping as well. So gray, white, black, clear, and then this is our fastest right here. Then over here we have like some engineering type resins. This one right here is a self-lubricating, kind of more durable material. This one right here is rated for higher temperatures, like probably up into the like 460 degree Fahrenheit range. Over here we have some glass-filled materials. Rigid 4000 is simulating PEEK, which as you might know is normally like a very expensive type of plastic to work with, but this is going to be less expensive, very popular. It has a little bit more ductility than, for example, the same type of resin that's also glass filled but way more stiff. This one right here is popular for making injection molds. Then we have some elastomeric resins here. So the 40A is just like, the hardness of that material. So this is going to be our softest. This is like 99.99% medical grade silicone. So if you wanted to make a ventilator or some kind of medical device, a lot of folks ask about silicone for that. Then flame retardant, and then we have a whole series, as you can see there, several different types of like ISO certified biomedically compatible resins that are certified to interact with living cells. ESD, P-rigid, these are specialized resins with really interesting chemical properties. For example, alumina 4N here, that's a technical ceramic, very popular like with aerospace application. It is rated to resist heat up to 3,500 degrees Fahrenheit. Thermosets like nylon 11, nylon 12, glass filled, polypropylene, nylon 11 carbon fiber, and the softer TP 50A shear hardness, so a little bit harder than the silicone, but not as hard as flexible 80A. So this would be the hardest of the elastomerics, like a bicycle handle. So every month we're going to come out with like a new material. $1,300 per liter. This is the material that can withstand 3,500 degrees Fahrenheit.
Give it a whack on there.
It is. It's technical ceramic. So, very strong. Part that was printed in resin, the foundation of it is the plastic part, but we work with a partner that does electrocoating with metal. So they were able to coat this in a bath of aluminum. So what started off as just like a plastic part became suddenly a very strong part after we plated it in aluminum. I'm like 250 pounds and I'm stepping on it. No problem.
Lightweight.
Yeah, and strong.